So more conics, but something a little bit different here. So we want to find an equation of a parabola, and we know some information about it. We know its focus is at 5, 0, and its vertex is at 1, 0. So some things we know about parabolas. We know we're going to have x squared or y squared. We don't know which one quite yet, but let's actually make this sketch. We can get a general idea of what this is going to look like based on this information. So let me draw that a little bit straighter. We know that our vertex is at 1, 0. Well, 1, 0 is about here. We know our focus is at 5, 0. So 5, 0 is a little bit further out here. So we know that our parabola is going to go this way because the focus is always in the cusp of this thing. So we know this is our 5, 0. And we know this is our 1, 0. And it also means that our directrix is somewhere back here. And it's going to be an x equals line as we go through and we work through this. But things to remember about the way that these are set up, because this will help us find our equation when we're done, because what we know about this is since it opens to the right, we know that this is a y squared equals 4px. Since it's on the x-axis, we know it hasn't been shifted up or down, but since the vertex is not at 0, it has been shifted to the right. So it does have an x translation on it, but it doesn't have a y because it hasn't been moved up and down. So we know that there's some h value in here too that we've got to account for, all right? So when we look at this, we say, well, how far has this thing been shifted? Where should it be? The vertex should be right here at 0, 0, meaning that it's been moved 1 unit. So we know this part of our equation. We know that that x is minus 1. We know that y squared is still going to be y squared. What we need to figure out is we need to figure out what this for p needs to be, okay? Now, one thing that we did know is we knew that normally the focus was p, but it's p with the transformation attached to it. One thing about a parabola, the vertex and the focus, the distance between those on that straight line is always equal to p, meaning the distance right here is p because it'll be the same distance to this directrix as well. So if we can find the distance between 1, 0 and 5, 0, then we'll know what p is. Well, 1, 0 to 5, 0, 1, 5, that's a distance of 4. So that means that p here is equal to 4. So that means when I come in here and I fill in this equation, I know this has to be 4 times 4. So what does that leave me for my final equation? That gives me y squared equals 16x minus 1. I could have done that even if it had an up and down translation if I had looked at the graph, because it would have still been on a straight line for me to ease it. I would have seen the same y values. I would only needed to subtract the x's for this one, okay? So making this sketch and understanding what this information tells us will enable us to work backwards. Let's try another one. Let's try a hyperbola. So hyperbola has foci at 0 plus or minus 10 and vertices at 0 plus or minus 6. So since these things right here are 0, we know that this hasn't been transformed, but these are y values. So this means this is going to open up on the y-axis. So let's sketch what this thing should look like over here. So our foci are right here. Our vertices are a little bit lower than them, and it opens on the y. Like this. So this is the 0, positive 6. This is the 0, negative 6. This is my 0, positive 10. And this is my 0, negative 10. Now, because it opens on the y, it does tell me some stuff about the equation. It tells me that the y fraction has to be positive. The x1 has to be negative because it always opens on the fraction that has a variable that's positive. I also know it hasn't been translated anywhere because it hasn't been shifted to the left or to the right. And because the distance, these two numbers are the same, I get 6s in both of these and 10s in both of those. I haven't shifted it up or down because those numbers would be different. So there's no transformations applied to this thing. So that also means that this is the C value and this is the A value. So let's write down what we know about the equation so far. We know it has to be y squared minus x squared. A is going to be here. B is going to be here. Clean that up just a touch. Y squared x squared. And it's going to be equal to 1. Now, we have a C and an A. What we also need to remember about these things is that this is straight Pythagorean theorem. C squared is equal to A squared plus B squared. So if I know two of these parts, I can find the third part, because the only thing I need to do to fill in this equation, I need to fill in what A squared and B squared are. Okay? So C squared, so we're going to put the 10 in here. 10 squared is equal to 6 squared plus B squared. So this is 136 plus B squared. So if we subtract that, we get 64. And the square root of 64, that's 8. So B is 8. Now this is where you got to be cautious when you write this equation. We're going to want to put this 6 and this 8 there. But these things need to be squared. So when we actually write this equation, A is the 6. And it needs to be squared. X squared is going to have the 8 with it. It needs to be squared. And to actually write that answer, yes, you're going to want to square those things. This is going to be 36. And underneath the x squared, we're going to have 64 equal to 1. So that's how you solve problems along those lines.